Okay, guys, so what we're going to do is we're going to expand on significant figures a little bit. Up to this point, we figured out how to identify the number of significant figures. So now we're going to do a little bit of arithmetic. Okay, so let's take a look at a couple of examples. When we're multiplying or dividing a set of numbers, your answer should reflect the number of significant figures as your least precise number, right? Now, what does that mean? So let's take a look at the numbers that we have here at examples 1 and 2. So the first example is an example of a multiplication. Now, what we're going to do is we're going to go through and we're going to figure out each number, how many significant figures they have. So the first number has 4 non-zero digits. So in this case, all of these numbers are significant. So this number here has 4 sig figs. Okay, so let's go ahead and take a look at our next number, right? In this case, we're multiplying by 3.14. Again, these are all non-zero numbers, and because they're all non-zero numbers, they're all significant. So this one has 3 significant figures. Okay, so let's go ahead and punch this into the calculator and let's see what we get. Now, when we punch this in, okay, here's what we ended up with. The calculator spit out this number, 67.2274. Okay, now when we look at this number, right, again, these are all non-zeros, right? So here I can see that we have 1, 2, 3, 4, 5, 6, right? 6 significant figures. So the answer that was given to us in the calculator has six sig figs. All right. Now, what I meant by your answer should reflect the number of significant figures of your least precise. So what that means is if you take a look at the numbers we multiplied, right, to get the product, we multiplied 21.41 times 3.14. The number that has the smallest sig figs, okay, is going to be this one. It's going to be this number right here. So what that means is that my answer could only be to 3 significant figures. Think about it as the analogy as a chain is only as strong as its weakest link. It's kind of like that. So when you're taking a look at this answer, right, if you present the answer to 6 significant figures, it's incorrect. If you present it to 4 significant figures, that's also incorrect because remember, the most precise or the least precise number that you have is only 3 significant figures. So to round this up, right, to shrink this down, what we're gonna do is we're gonna round and we're gonna try and get it to 3 significant figures. So how do we do that? Well, if we take the number 67.2247, right, that's the answer. Then 3 significant figures is here, right? There we go. So what I'm going to do is I'm going to use all these numbers and I'm going to round them up, right? So let's take a look. If I round up the 7, the 4 becomes a 5, and the 2 becomes a 3, right? Because we're rounding up, right? Now, because this 3 is not greater than 5, then that means that this 2 can stay exactly where it is, right? 5 or more, add 1 more, 4 or less, let it rest. I think that's what my kids learned in school. So because that 3 is not enough to round up to 2, then my answer becomes 67.2. Now my answer is sitting to 3 significant figures, and I rounded up correctly. Make sure. So here we've taken this huge number, right, or long number from the calculator, and we successfully rounded it down to get it to 3 significant figures. So this would be the correct answer to 3 sig figs. Okay. Okay. So this is the same process we're going to follow when we divide. So let's take a look. Here we have 4.11, okay? So because these are all non-zeros, these are all significant. So this number here has 3 sig figs. All right. Remember that leading zeros are not significant. They're placeholders. So these are not going to be significant. And these 2 non-zeros are going to be significant. So this number has only 2 sig figs. Okay. So let's go ahead and punch this into the calculator. All right. And let's see what we get. So 4.11 divided by 0.031, the calculator spit out this number, 132.580645 All right. So just based on this, right, I see a lot of non-zeros, and the only zero I see is between two non-zeros. So this number has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This number has 10 significant figures the way it was presented in the calculator. So this is 10 sig figs. Now, our answer can only be to the significant figures that of the least precise number. So that is this one, right? So our answer then should be in two significant figures. Now, how do we get this huge number, right, to two significant figures? Let's take a look. So for this one, because the answer is a three-digit number, right, saying here before, after, or before the decimal, right here, right, we're going to use this number to round up this one. Now, the 5 is 5 or more, so add one more, right? So that's going to get me to 133, right? But we're still not right because, look, if you take a look at this number is sitting at 3 sig figs, and our answer should only be in 2. So what I'm going to do is I'm going to take a look at this last 3 right here, and I'm going to be like, okay, can I round this up to 140 or can I round it down to 130? Because it's less than 5, I'm going to just take this one down to 130. Okay, 130 without the decimal point has only two significant figures. So the correct answer here would be 130, right? And that's how you adjust your answers to the correct number of significant figures. Okay, now what happens when we're adding and subtracting? So this one's a little bit different, right? Because what we're looking for here is not so much the number of significant figures, but the decimal places, right? So when we're doing addition and subtraction, right, and we want to get the number to the correct number of significant figures, then we have to pay attention now to the decimal places. So let's take a look at the first one. The first one says we have 42.1 plus 1.411, okay? So this one has one decimal place or one digit to the right of the decimal, and this one is 3 decimal places. The least accurate number that we have is going to be this one, right? And this one only has one place. So because it has one place, our answer can only be to one decimal place. So what happens when we split this into the calculator? You really don't need a calculator, but let's just go ahead and do it. So when you add these two numbers exactly as they are, you're going to end up with the answer 43.511. Now, we've already said that we can only go to one decimal place. So what am I going to do is I'm going to take this number and I'm going to use this one to round this number, right? So because the 1 is less than 5, then the 5 stays, and my answer then becomes 43.5. And that would be the answer that you would use. Now, keep in mind, right, that here we still ended up with the correct number of significant figures anyway, but our focus in addition and subtraction is the decimal places. Let's go ahead and take a look at another example, okay? Here, I can see that we have 3 decimal places, 1, 2, 3, and here I can see that we have 2 decimal places, right? So because my answer is the least precise one is only to 2 decimal places, then my answer should be to 2 decimal places. Now, when we split this into the calculator, again, I don't think you need one, but when you do, 9.144 is the answer. All right. Now you can see here that this number is clearly to 3 decimal places, and our answer should only reflect 2 decimal places. So I'm going to use this number here, and I'm going to use that to round this one if I needed. 5 or more, add one more. 4 or less, let it rest. So because this one is at 4, I'm going to keep the 4 exactly the way it is. I'm not going to round it up, and my answer is now going to be 9.14, and we ended up to the correct decimal place. And if you look, we still ended up with the correct number of significant figures. Okay, remember, trailing zeros are significant if they're to the right of the decimal. Okay, guys, that's pretty much it. Make sure to add this to the left side of your notes. And if you have any questions, please let me know.